Hi guys, I'm sorry I couldn't be here with you today, but I have a few short videos to show you. They're not going to be very long, but I can't upload them to YouTube if they are too long, so it's just 3 short videos that you're going to go through. This is going to be on the bond energy and thermochemical equations, so I don't have those in your notes packet, so you're just going to be taking these as regular notes. So if you want to get something out right now, to do so, go ahead and pause this if you need to. Okay, I'm still new with this app. We've used this before, but I need to make sure not to go too fast here. So if we are looking at bond energies, what we're talking about is a way to calculate delta H. Alright, so we've been using delta H. We used it when we did the heating cooling curve. We used it when we did enthalpy. But now we're looking for a way to calculate it. Now, 2 things that you need to know are, I don't know why that, let me put it out, there we go. 2 things you need to know are that bonds are broken in your reactants, and then bonds are formed in your products. And that's how a reaction actually happens. We break the bonds and then we form the bonds. Now all of that is associated with a change in energy. This is the most important thing that you need to know here, is that it takes energy to break bonds and it releases energy when we make bonds. So this right here, this positive delta H and this negative delta H, those are very, very important, and that's on the front side of your packet as well. All right, so it takes energy to break a bond, and it releases energy when you form a bond. So a positive is associated with broken bonds, a negative delta H is associated with bonds formed. And I think we talked about that once when we did intermolecular forces. I told you to hold your hands together, and if it would take somebody energy to break your arms apart, which it would. Okay, so it takes energy to break bonds, not the other way around. Now, what we're doing with this today is we have to figure out when a reaction is endothermic and when a reaction is exothermic. So I've made a little table here. I'm going to write this a little bit faster. And we'll pause it here. But when is a reaction endo and when is it exo? What you already know is that a reaction is endothermic when it's a positive delta H, and it's exothermic when it's a negative delta H. Oops, sorry. Let me go back there. There we go. So it's positive when it's endo, it's negative when it's exo. When the energy used to break the bonds is greater than the energy released when forming, then that means that you've put in more energy than you've released. So that means that it's a positive delta H because you've put in more energy than you've released. When the energy released when forming bonds is greater than the energy used to break the bonds, then you've released more energy than you used, and that's why it's a negative delta H. Okay, so how do we know? What we do is we use a reaction in the dissociations table that you've been given. Oops, sorry. And the dissociations table you've been given. Here are 3 examples. Okay, so we use our reactions. Now that little table, you will get one of those for your test. Okay, you obviously not have to memorize that, but it's very easy to use. How we know how much energy something takes to break or make those bonds is we look at that table and let me go back a little bit here. We use that table and we figure out where our bond is on the table. So the first one is a hydrogen bonded to another hydrogen. So we go down to hydrogen and then over hydrogen, and we see that it's 432 kilojoules. These are always kilojoules. For the second one, it's hydrogen bonded to oxygen, so I go over to hydrogen, down to oxygen, and I see that it's 459 kilojoules. Okay, again, these are all kilojoules. And then finally I wanted to point out the last one, because this is the only one, if you notice, that has a double bond here. Okay, down in the bottom you see where it says multiple bonds. You can look those up right down there. So I would not go down to oxygen and over to oxygen here. Okay, I would not use that number because that's not a double bond. I would have to go down to my multiple bonds and use the oxygen-oxygen double bond. So my delta H for oxygen and oxygen is 494 kilojoules. This table is very easy to use. All right, you truly just do it like that, and you'll have this for your test. So when you look at molecules drawn out, all you have to do is look at the table and find how much energy it takes to break them and how much energy they give off when they are formed. Now I'm going to show you what to do with the reaction. All right, so this is going to be all for this video because I didn't want to get too long showing you how to do a reaction. So if you could flip to the next video.